This episode of Serverless Chats is sponsored by New Relic and Amazon Web Services. This week, I chat with Rodric Rabbah about statefulness and serverless. This is Serverless Chats, episode number 78. Hi everyone, I'm Jeremy Daly and this is Serverless Chats. Today I'm chatting with Rodric Rabbah. Hey Rodric, thanks for joining me.
Hey Jeremy, thanks for having me. I'm really excited about our discussion today.
Awesome. So you are the co-founder and CTO at Nimbella. And I'd love it if you could tell the listeners a little bit about Nimbella, but I'd really love to hear about your background as well.
Okay, yeah, thanks for giving me the opportunity. So I started Nimbella about 2 years ago, just over 2 years ago. And it was after a long stint at IBM. I was at IBM for 11 years in IBM research specifically. And there I did a number of things that touched on programming languages, compilers, hardware synthesis, and FPGAs. And the last project I really did was creating IBM Serverless Functions offering, which is now called IBM Cloud Functions. But it started as OpenWhisk. And OpenWhisk is now an Apache project that we've donated to the Apache Foundation a few years ago, and really is what started my serverless journey 6 years ago. So my background is mixed. It has experience from programming languages, compilers, hardware systems, and I've done a lot of things that I think have a common theme. I cross verticals, or I build verticals that cross lots of different layers of the stack.
Awesome. All right, so I want to start with IBM and OpenWhisk because this fascinates me where, 6 years ago and just recently, it was the 6-year birthday of AWS Lambda. And I think it's that this sort of kicked off a massive sort of investment and maybe almost like a space race, except for the cloud, I guess, a serverless race against all these different vendors. So you were involved with this very, very early on, right? I think it was your project, right? So I'd love to hear how this all came about. Like, why did IBM suddenly say, okay, we need to build a serverless offering?
Right. So before I started working on OpenWhisk, I was doing something completely different. I was debugging hardware and looking at how to generate hardware from software. And then we saw the Amazon Lambda announcement at the time, and it was literally right around this time. And as soon as we saw it, it was sort of one of those moments where you just realize, oh my God, this is a dramatic shift in technology that's coming. And even though it was basically day zero, you could see, from the right perspective, you could see what the future is. And now I say serverless is inevitable because, whether you're on the bandwagon or not, you will be in the future because that's the only way developers will want to build. So in the early days, we saw the announcement. We were looking at the project we were doing. They gave us the terminology that we were looking for. It was just take code and just run it in the cloud. And we were trying to do something like that with hardware. Take software and now we can accelerate it for you on an FPGA, which is reconfigurable hardware, without you having to worry about compilation and running. And so we were doing work in a similar context, in a similar area, but a completely different context. When we saw it, it's like, this is it. So we got together as a small team within IBM, 6 people, and we were having discussions about Lambda and the future and what does it mean for IBM Cloud. And, from IBM research, our job really was to sort of look at technology that's on the horizon and, 5-10 years in the future and start thinking about what does that mean. And after about, a few weeks of just talking about it, I got tired of talking about it. And over a weekend, I built the first version of what became Apache OpenWhisk. And it started with, a command line tool, which was the programming interface essentially to the cloud. Allowed me to create functions, run them, get their logs, and recorded a short video by Sunday night and then sent it in, Monday morning. It got in front of the right eyes, that whole thing about being at the right place at the right time. And it started circulating. And from there, we're like, okay, this is turning into something. And off we went. So it was sort of the Amazon Lambda landed on the scene. There was recognition that this is something really transformative into the future. And then the will to just build something. And once you start building something, I think good things start to happen. When you're surrounded by good people like we were at IBM, and the project grew. We were 3 people. We launched the early version of OpenWhisk internally. It was called BlueWhisk, I think, at the time. And I think within 1 year of when the first commit to the project started to when IBM announced at their big developer conference, it took us basically 1 year from commit to launch. And we launched out of IBM Research, which was, again, unheard of. And right around the time we launched, Google Cloud announced functions, and I think Azure also announced functions. So we weren't the only ones sort of that saw this shift coming. And everybody really started basically saying, oh, yeah, there is an arms race here, or space race. I'm really excited because it's sort of transformed what I've been doing. And I think it's been really exciting and rewarding for me.
So I absolutely love this idea of these sort of ideation or these genesis meetings that happen in organizations where you're like, all right, there's this major transformational shift that's going on there. So to the extent that you can, and again, I don't know if there were executives in there or who were in that meeting. You don't have to disclose that. But to the extent that you can, take me inside that meeting. What was the conversation? Was it like, oh, we just need to do this because we need to compete with Lambda, or was it, or we need to compete with AWS, or was it something where the structure of IBM Cloud realized that this truly needed to be done?
Right. So it was a bit of the latter. And in fact, when we started coding, we tried very carefully not to use the word Lambda anywhere. That was sort of just IBM bureaucracy that maybe was ingrained in us. But it was a bit of latter. I mean, I remember the meeting very well. I remember who was in it. I remember where everybody was sitting, because it was that kind of transformational meeting, at least for me, and as I saw it. And it was a recognition that, if you wanted to move applications to the cloud, or you wanted to transform an organization and become more, what people call cloud native, basically using the tools and technology of the cloud, you had to do something different. And what we had been doing wasn't quite working. This whole shift on lift strategy doesn't quite transform your business. And to do the value innovation and sort of pushing up the stack to extract more value out of your organization, you had to do something like this. There wasn't complete buy-in. I mean, as we started the project and as we built the technology, we were fighting against currents that were trying to drag us in different ways. Containers and containers as a service was just getting started. Kubernetes was just, landing on the scene in terms of popularity. And we had to basically say, no, the future is here. And we built and tried to control our destiny as much as possible. There were senior directors, and as the team grew and we were presenting to more and more people, there were executives, IBM product line managers, and by the end of the first year, our calls were fairly big. We were doing two-week sprints, where every week we used to call them shock and awe sprints, because what shock and awe features can we deliver in the next 2 weeks? And that became a theme for our team, and it was really fun to do, because as we did this, we were sort of operating the prototype internally. More IBMers would sign on and start using it. And we started using it. And so it was really exciting. And by the end, we had a lot of buy-in because, IBM Cloud Functions had to be launched, and that needed sort of a business line justification and buy-in. But early on, I think it was primarily out of research but it was senior directors who were sort of participating in that conversation. And so it was really exciting. So thanks for letting me relive some of that. 6 years ago.
Well, no, that's awesome. I mean, again, like I said, that idea of the vision, it's hard sometimes. I think it's really hard when you're in technology to sort of pick what's the next big thing. And again, we've got a lot of serverless haters out there and people who still love containers and Kubernetes and all that other stuff. Not that they necessarily have to compete, but I do love that when you are at that moment and that meeting where you say, this is it, this is the next thing. So that's pretty exciting. But now you mentioned in there this idea of lift and shift, right? And this is something where I think most clouds took this strategy very early on to say, how can we meet customers where they are and make it very easy for them to just take their on-premise applications and move them into the cloud, which is why we're loaded up with virtual machines, and EC2, at least in AWS Cloud, I think is still the biggest moneymaker that they have there. But with this transformation to serverless, I mean, you have a lot of limitations. There's a lot of refactoring. Sometimes you completely re-architect your application. But what about just building this in general? I mean, there must have been a lot of technical limitations to get around, right? I mean, I know AWS, I think, first started building their stuff on EC2 instances. Is that how OpenWhisk started too? You just running on virtual hardware?
Right. Yeah, there's so much there that I would love to talk about. I'll see how many of these I can peel off. We knew we had ideas of how Lambda was running and executing. And then we looked at how can we build this. Obviously, we had to run on IBM hardware and the cloud that IBM offered us. And that did put some constraints on how we actually architected the system. Some of those features, if you want to call them that today, are still with us. And I think have played to our advantage, especially as the Apache project has moved towards more of a Kubernetes native sort of layer that you add on to give you that serverless experience. But early on, we were deploying on VMs. And to auto scale up and down, it required many minutes. So it wasn't latency that you can sort of just easily hide. And so that meant that we had to rethink or sort of think about the heuristics that we would build to give you that elasticity, that serverless illusion of I can run 1,000 functions and some other user comes along and runs 1,000 functions. Hey, they just scale and they all run. So we built a bespoke scheduler and a custom heuristic for how we do the scheduling. And it did influence essentially the architecture because we just couldn't bring up new VMs fast enough when we needed it. Right. So there was a bit of that constraints that played into it. I think this whole notion of containers versus functions is really still with us. And it's for a number of reasons. Some of them you touched on. It's hard. And to go into serverless, you're re-architecting applications. So it just doesn't fit the shift and lift model. It's fundamentally opposed to that in a sense. And so shift and lift looks attractive, but to really buy into and get the benefits of what serverless promises, this whole notion of less operations, more focus on value creation, it's necessary that you sort of re-architect. So the key is gentle migration and acceptance that there will be a mix of technologies, containers, VMs. And so our solution was to pick containers early on, and that allows us to also run containers as functions. So we started with, I think the first runtime we had was Node, and then we added Python after that. But very early on, people said, well, I'd like to run my Java application, or I'd like to run some other language that you don't support. So we were able to say, okay, bring your container. So very early on, OpenWhisk offered, and we might have been the first that maybe offered this mix of functions as code, basically zip file, and functions as Docker containers that you just pull from a Docker registry and just go. And I think that helped people in sort of the gentle migration, sort of shift and lift. Okay, I buy in, I start to get a taste, and then I start refactoring. And I think that's how you still have to do it today. It's sort of this whole gentle migration step.
Right. Yeah. And I think you make a good point about the hybrid stuff. I mean, for a very, very long time, especially for any larger business who is already either partially in the cloud or is migrating to the cloud, there's going to be a mix of everything, right? There's going to be VMs, there's going to be containers, and hopefully they start moving things into serverless. So when you built this, though, so you built this bespoke scheduler you talked about, you've got, it's running on VMs, you eventually adopted containers and so forth. But when this launched, like this was ready for prime time, right? Like this wasn't like a little side project thing that just happened to go into production. I mean, this was like enterprise grade, right?
Right. So we launched February of 2016, I believe. And we had already been in production for several months at that point. Maybe 2015? No, it's 2016, right? And it wasn't still, the code was quite mature. And I think we just recorded another podcast with some of our early partners. Adobe jumped on the project fairly early when we open sourced, and they were the impetus essentially for joining the Apache Foundation. So the code quality was solid in that regard. And I used to joke that, hey, the system is bug-free. And I meant, it wouldn't crash for a segmentation fault or things like that. And it was true. It sort of held up for a long time. We didn't have our first real crash from a seg fault for like 2 or 3 years. And I remember it because somebody slacked me in our IBM channel said, "But you said this was bug-free." so it sort of stuck. No, it was ready for prime time. We were already doing many thousands of containers a day, sort of churning through containers. And our solution was basically you take a function. We didn't create containers per function. We had this notion of stem cell containers, which are unspecialized containers ready to inject code into. And then once you did that, they became specialized for a user and for a function. And that allowed us to sort of do things with speculation. We can pre-warm containers and really allows us to deliver performance that was on par with Lambda. And independent benchmarking today still shows IBM Cloud Functions, which is probably the largest deployment of OpenWhisk. Maybe Adobe would be second. Does extremely well against Lambda in terms of latency and throughput. So it was really looking at sort of how do you deliver performance, how do you build this technology, and then how do you meet people in terms of giving them a gentle migration step towards this new paradigm.
Now, I know you've been removed from IBM for a while, but it looks like the project now, the preferred way to run it is on top of Kubernetes.
Right. So OpenWhisk, like we said, started on VMs, but just like with serverless and Lambda, and you saw that it was a future here that was inevitable, I think Kubernetes quickly started eating up every other container orchestration system on the planet. And so we had to shift the open source project, to support Kubernetes. And IBM also had to do this migration. We were already live in several geographies around the world. And so we started with one region, moved that to Kubernetes, operated that for a while. And then, the team got the confidence to roll that out. And that was right around the time, actually, I was leaving. I think they had just launched the first on Kubernetes version of Cloud Functions, and off they went. So the project now is Kubernetes native, if you will. Basically, you can deploy it with a Helm chart out of the OpenWhisk Apache repo. But we did something different. And this is where maybe OpenWhisk stands out against some of the other Kubernetes serverless platforms out there today. We don't delegate the container orchestration to the Kubernetes controller and the Kubernetes container orchestration system because it's too slow. If you're looking at the kinds of workloads that are short running or that are Lambda style, where you want to invoke really fast, get responses. I think I've seen a number of studies that said the average execution time for a Lambda is well under a second and even several milliseconds. Spinning up containers that fast on Kubernetes just doesn't work. It wasn't designed for this. And so unless you solve the problem deep in sort of the Kubernetes scheduler, you have to bypass Kubernetes for container orchestration. And so OpenWhisk until today really does that for the large enterprise deployments. You can delegate to Kubernetes, or you can sort of bypass and use a bespoke container orchestration system that really allows you to sort of deliver the best performance. So if you want Lambda anywhere other than AWS, there's really only one answer in my view, and that's the OpenWhisk project.
Right. All right. Well, we don't have enough time to discuss and solve all the K8's problems on this podcast. Hey everyone, I want to take a moment to thank our sponsor, Amazon Web Services, and tell you about the new Amazon Managed Workflows for Apache Airflow. Amazon Managed Workflows for Apache Airflow is a managed orchestration service for Apache Airflow that makes it easier to set up and operate end-to-end data pipelines in the cloud at scale. With managed workflows, you can use Airflow and Python to create workflows without having to manage the underlying infrastructure for scalability, availability, and security. Managed Workflows automatically scales its workflow execution capacity to meet your needs and is integrated with AWS security services to help provide you with fast and secure access to data. Data engineering just got a whole lot easier. Learn more at serverlesschats.com/managed workflows. So you left IBM and you started. I guess let's set this up for you. You started Nimbella, right? And I want to get into Nimbella because I think this is really fascinating what you and your team are doing over there. But what was it? You explained it a little bit, but what was it about sort of the current landscape? I mean, you already built OpenWhisk. It had a tremendous amount of success with IBM. With IBM Cloud Functions, it went into Adobe, and you've got all these people using it. But you basically said serverless isn't good enough. And you did this other thing. So what was it about the market or the current landscape that made you say, we need to do something different here?
Yeah, we needed to do more. I think that's the best. It's like, yeah, this is great, but we could do so much more. And to me, I sort of really view this as, the introduction of Fortran for the IBM mainframe. we're at that level of innovation in terms of how early we are on this journey. And it was a recognition that, hey, there's a lot of problems still unsolved, from how do I debug? How do I look at this whole notion of now I'm breaking up applications that were large monolithic into smaller fractions? There's rich opportunities for system and dynamic feedback optimizations where, if I start with a bunch of functions, do I fuse them together and run them as a monolith because it's more efficient? What about taking advantage of resources that are specialized, like a GPU or a TPU if you're doing AI and TensorFlow and things like that? So it was sort of looking at it from a pragmatic perspective, saying there's a lot of opportunity here to do more, and recognizing that from the technology perspective, it was so early. It was hard for developers at large enterprise to really get started. And it came from a number of reasons. One was this whole notion of how do you build for the serverless style when you can't quite run locally, you can't quite debug your code in vivo. And watching some of IBM's early clients sort of adopt this technology, be successful in the end, but what it took to get there, the questions that they were asking, in some ways influenced my thinking as we started Nimbella. And it wasn't just to compute. I think functions as a service touches compute. It ignores the whole data aspect of applications. And really, this is where I started. It was like, okay, we've got this model for compute with serverless functions. We've got container as a service. We can mix the two. What about the data model? Mm-hmm. And looking at how do you marry a serverless data model? What does it even look like with compute? And that's where the genesis for Nimbella really started. It's like, I want to be able to build complete applications. I want to deliver this promise of, don't worry about the resources being allocated for your data. Don't worry about replicating it. Don't worry about some of the synchronization and consistency models. Because for a lot of those, there are good solutions that we've learned over years of sort of distributed systems research and technology that we've built. So I wanted to bring the two together. And that's what really started Nimbella. Like, can we do this? Can we do this marriage of stateful and serverless and bring them together so that we can continue to deliver on this promise of, hey, as a developer, I just want to build. Everything else should be taken care of for me.
Yeah. And I think I think we should probably just sort of define state, or at least give the listeners a little bit of background on state. So, with serverless functions, or at least with the traditional serverless functions we've seen, over the last several years, there's no shared state in the sense that, when you reload or when you execute a function again, that it's going to have all this information there, especially because every single request typically runs in a new container. And even if it runs in an existing container, there's no guarantee that it's going to run in the existing container that you were just in that has the same data there. So I know that AWS has added things like EFS integration, and there's more things that are happening there. But really, even with something like EFS integration, most of the time when a function triggers, if you need data in there that wasn't passed in as part of the event, you need to rehydrate that data. So maybe we can talk about the kinds of state that you would need in a typical application, and which ones really are kind of missing from serverless.
Right. Yeah, I think you've really framed it exceptionally well. And I describe it in terms of locality, right? So when you're running functions in Lambda, or really any serverless platform, you don't know where your code is running. You don't know the container, you don't know the resource. So every data you need to touch, you have to move, and you lose data locality out of that. So you're spending time transferring data back and forth. That has both an economic impact, and maybe even from a sort of an eco-friendly perspective, right? That's wasted power. And so by being data locality aware, you can bring back computational efficiency that we know from traditional building of systems is important. And so our approach really is about looking at, to be able to scale a function to thousands of instances, the system has to say, hey, look, the state is on you, right? Because it becomes much easier to spin up 1,000 containers without having to worry about consistency, sequentialization, et cetera. But then you're leaving the burden on programmers. Now you've given them this supercomputer that's basically a distributed system and said, okay, go figure out the rest of the data synchronization model that you need to do. And that's where, things are lacking. Can we do better? And at Nimbella, I do think we're doing better. One of the approaches we're doing that is with a declarative approach. So if you're a function or even a container, you can say, here's the state I want managed for me. And so what that means by being able to declare that, it could be, for example, a file that you need to load because you're doing machine learning inference. So you need to load the machine model that you've pre-trained with your neural network. Every instance of that function doesn't need to load the same file. If you could load the file once, mount it and share it across multiple functions, now you've saved the cost of maybe 1000x because you're not doing 1,000 times. And moreover, if you're reusing containers, it's already there because it's been hydrated, as you said. So that's one example of sort of looking at different kinds of state that can be managed automatically by the system, files. And these are things that might be stored in an object store, for example, and then mounted as actual files that you can use within their containers. So I like to think of it as state because the system can manage it for you a bit more efficiently. In fact, you can't even do it at user level. I think this was sort of the fundamental primitive for us was like, if I'm a user and I really want to do this, maybe with EFS now you can do some of these as you were touching on, but I can't. The system doesn't allow me to do it. So unless you have the deep integration within the platform, you don't get that computational efficiency from locality. Another aspect of state that we also take a declarative approach to managing is sort of transient state. These are things that you would put in Elastic Cache or Redis. And these could be, for example, session tokens, OAuth flows between Stripe, Okta, or whoever you're using sort of identity management with. And you need that state, you need to store it somewhere. And sometimes you just need a very lightweight database. It's a key value pair. So can we just provide that? And it's just there for you. And these are some of the things we do at Nimbella. So when you write a function at Nimbella and you just want a counter that's persisted and shared across functions, it's just there. You just say, for this key, bump the counter. You don't know where your Redis instance is located. That's our burden. You don't know how it's backed up. That's our burden. You don't know which geography it's running. The only thing you know that your functions can touch that store with sub-nanosecond latency, sub-millisecond, so nanosecond latency, because we've taken on the job of making sure that your compute and your data are co-located. And so we're delivering that performance. We're delivering that aspect of state management that is really starting to deliver again on that serverless promise, but now it's also stateful. So our approach is really to look at what kinds of things people are doing. And we've categorized 4 of them that we've sort of focused on today. It's static assets when you're building application that you want to deliver out of a CDN. So that's one. It's files like the machine learning models we've talked about that you might store in an object store, but then give you essentially an abstraction that lets you treat them from functions as a file system, and then key value store. So for a transient state. We've left some of the harder problems for our future roadmap, things like databases. Now I'm talking about RDS. And so our goal there is not to build all of these things ourselves. In fact, that's a key aspect of what we're doing. We're not building our own cloud in the sense that we're not managing infrastructure. We're building on top of existing cloud providers that do exceptionally great things. It's just too hard for many developers to penetrate. So we just take the existing clouds as a commodity and build these important layers of abstraction on top of them.
Right. Yeah, and I think that's it's a good point you make about sort of, I mean, I don't know exactly how you worded this, but this idea of sort of like making it abstracting it away for developers, right? Like making it so it's sort of clear that they don't have to do it. Now, I have concerns about adding state to serverless because I think in some cases people would just use it as a crutch, right? And sometimes when you make things available to people, that's when you get serverless WordPress and things like that maybe you just shouldn't be doing, right? But I do think there are a number of use cases where you do need it, but also it's sort of, I think just for me personally, I like to really find a way that I can pass as much information in the event as possible so that you can maintain that statelessness. Because again, the promise of serverless is unlimited scale, or at least, massive scale, right? So now if you're mounting EFS volumes or you're connecting to some file system or something like that, now you've got potentially thousands of concurrent users that are all accessing the same file system and so forth. So there's just a whole bunch of other problems that get introduced there. But I think that's really interesting. So I don't know. I mean, what are your thoughts on that, though? I mean, do you adding state is a great thing for a lot of use cases, but at the same time, I mean, are you still in the camp of, serverless should be as stateless as possible when possible?
Yes, and that's because the history of computing has shown us that's the best way to sort of get computational efficiency. And maybe this is important in terms of my background, right, where we started this call. I've come at this from a programming language and compiler perspective. And so I'm just looking at, hey, I can optimize these with a compiler if I had the right abstractions. And what serverless has allowed us to do is basically be prescriptive, right? When we launched IBM Cloud Functions, or when Lambda came out, Amazon said, write your code like this. And people wrote their code like that because the carrot was so big, they just followed the recipe. And yeah, demanded more features, demanded more capabilities, and that came over time, but it's given us the opportunity to be prescriptive. And in some ways, because the hardware has come first, the cloud is this massive supercomputer. It's available. It's allowed us to essentially say, oh, we can do distributed programming now with the right programming language abstractions and be prescriptive, and people will do it. And so that model that you just touched on has roots for me in sort of actor-oriented models where your function is essentially an actor. And you can think of the steps of execution, the life cycles, as being broken up into pre-work, so things you do before you actually start running your function, the function itself, and then post-work. So opportunities to do things like, hey, fetch data from a database, or fetch data from a key value store, or a file system can be done in the pre-work. And then when I'm done with my function, hey, serialize all this back out to the right places can be done in the post-work. And what's important about sort of thinking about these three phases of execution is that the first, the top, the pre, and the post can be completely managed by a system if you can take a declarative approach, or other approaches for sure. But at least that's how we've come at it. What that allows you to do from a functions perspective is just have this really clean abstraction that says, here's my event. My event contains some state. I don't know where it came from. I don't care where it came from. I can write my code against that event. What's happening before and after is now hands off. And that ties back to the serverless promise. Just write your code, right? You can think about your interface, your API, and then everything else is managed for the system. How much of that can we do? I mean, that's how we started. It was like, how much of that can we do? And this is where, the genesis for our company, which really was. And we found that, for a number of these kinds of states, we can do extremely well. And the benefits from the end user are, hey, the abstraction of the function is still pure. You didn't have to break that abstraction. How far can we push it? I mean, this is where it's still early, but this is what we're trying to do.
Yeah. So speaking about before and after, another problem and a question that always comes up, has to do with function composition, right? And we always think about single purpose functions. That's the way that we recommend you do things. I mean, this function converts the image, this function processes the record, and then it sends it somewhere else. And you can do that with, choreography, right? You can just sort of hope the next system picks up. But state machines have been something that most people embrace when you're trying to connect multiple execution components, or if you're composing functions, state machines are really helpful. So what do you have at Nimbella to help with those kind of workloads?
Yeah, so what we have, actually, we inherited out of OpenWhisk, and some of the early features we put in OpenWhisk, it wasn't. We talked about bring your own container and run your container as a function. The other was composition. It was built in from the ground up. It was sort of an intrinsic into the system. What that allowed you to do, for example, is take functions and then chain them together. So you have a pipeline. And later on, and this was sort of, we did it in a way where the composition itself looked like a single function. And what that means is that you can take it and then further compose it. So it really goes to sort of, from a software engineering perspective, coming up with libraries of reusable assets that then you can take and treat as malleable code that you can integrate in other components. And later on, we went from just composition, sort of a sequence, to, hey, let me write an arbitrary state machine, a data flow graph. And we have, again, open source that came out of IBM research called Composer, which is very similar to Amazon step functions in that it compiles down to a state machine. And but you can code to it against the library from Node.js and Python. And I think Amazon is just starting to do some of that work. We've done it back, 2 years, I think, before. This is one rare area where we had innovated something faster than Amazon. So we're really proud of that work. But I think composition is important because of some of the things you talked about. If you have the ability to focus small pieces of code on specific functionality, and then build them into larger applications using the right models, a state machine, you can again bring in this way of sort of saying, well, I can retransform this program. I can recompile it into something that's completely different. And it's easier to do that when you're starting with small building blocks than taking a large piece of code and then breaking it down into smaller pieces. And when you start small and go and coarsen, essentially you go from fine grained to a monolith. You can still deliver computational efficiency. You can scale things out as much as you can. When you go the other way around, you start hampering some of that. Your attack surface also gets bigger. Your boot times become longer. There's a number of things that become, as hard as parallel programming really still is today. So I like the model where you start with small, fine-grained pieces of code and then coarsen it. One API for per function. That doesn't mean you have to package the code exactly that way. I mean, things like Webpack solve some of those problems today. So I like the model starting small, building graphs, essentially state machines. What I think is fundamental, and Amazon, I think, will eventually get there, is, can you take these state machines and further compose them, right? Can you call step function from one step function? Can you call from one workflow? Can you call another workflow? Right. This touches on something we published out of IBM called the serverless trilemma. Basically, can you treat this code as an opaque piece of code that is no different than a serverless function? Code in, event out, and what you run inside, whether it's a single function or a whole workflow, is opaque to you as an end user. If you could do that and solve the double billing problem, basically, you're not waiting for your workflow engine to also run. And support just black box code that you can't modify as the vendor, then you've satisfied the serverless trilemma, and that's sort of like the zen of serverless compositions for me. Right. So we built essentially a serverless trilemma satisfying composition with OpenWhisk, and since then, people have sort of quantified and looked at, well, step functions does it this way, durable functions from Microsoft do it this other way. And I think we're sort of trying to define the space around compositions. So what we're doing in Nimbella is sort of inheriting a lot of what we did with OpenWhisk and building on top of that project.
Nice. Yeah, and that's another point you make about, using these or building these little reusable components. That's another really good argument for statelessness in those components, because if you want to reuse a component, but it's always saving to the same database or something like that, it's better to have something that maybe converts that object into whatever format it needs to be, past that then using a state machine to another function that maybe then has the ability to save that state and things like that. So that's really interesting. So I want to talk a little bit more about Nimbella, though, because I think an interesting approach that you took was, again, this whole thing runs on top of Kubernetes as well, right? And you can also run it on premises. So you can basically run it in any cloud or on-prem.
That's right. And I think we've done this in two ways. One is, we have a hosted service. And if you're an end user who just wants to build against the cloud, and you don't care about which cloud you're running on, you don't care about anything but time to market, right? Time to solution. We're building a cloud that's basically very easy to get started. And it goes to sort of this notion of building projects, building entire applications that incorporate compute, front end, back end, state, and just deploy. And it's a repeatable unit of execution. Somebody else could take that code and deploy it and run it. For the on-prem, we're essentially trying to say, hey, we can bring that experience for you wherever you're running your cloud. And the motivation for us behind doing that is a recognition that a lot of service providers out there are building their own clouds, and they need functionality like what serverless functions give them. They have events. They want to be able to allow their end users to operate on those events. You've seen it with Auth0, Twilio, Salesforce, Zoho now even has a serverless offering. And I think it's just, that repeating pattern that I have events, I have an ecosystem that my developers code against. They want this kind of serverless experience. And so we're essentially saying we can accelerate your delivery, and we can do it in a way where you can run it on any cloud of your choice. It's basically like saying we can bring the Amazon experience for you, wherever cloud you want. Now, that's too big to say because we don't do everything that Amazon does. We do maybe 3 or 4 things. But that's the reason we've sort of approached this whole model of Kubernetes. It allows us to say Kubernetes is almost everywhere. Every organization we talk to has now says, well, we have in-house Kubernetes expertise. So we say, great, point us at your Kubernetes cluster. And within 30 minutes, we've deployed this entire Nimbella stack for them. And they can start coding, building projects and deploying them. And I think that's what's been very powerful for us, being able to reach those organizations, help them fill gaps in their portfolio in terms of being able to offer these capabilities. We never expose Kubernetes to the end user. It's an operational aspect. So it's just a normalizing platform for us. And because it's everywhere, it's allowed us to basically say we can run everywhere.
Awesome. Hi, everyone. I want to take a minute to talk about New Relic. Now, I know when it comes to things like observability and tracing, you're probably thinking I should talk about Datadog, Prometheus, or even OpenTelemetry. And a few months ago, I would have totally agreed with you. But New Relic did something a little out there. They literally reworked everything. They've actually been listening when people talk about blind spots, being stuck with a dozen different tools, or getting hit with hidden costs. So first, they went open source, making it so that you can actually instrument whatever you need. Then they made it so that you can monitor your whole entire stack in one place, including your serverless workloads. You can use telemetry data from any source for ridiculously cheap, and there's just one UI with all the tools you need. Plus, they completely changed their pricing to a consumption-based model so that you can easily predict your bill. Now, I love this pricing model because it scales as my cloud application scales, which feels a lot like serverless to me. And best of all, there's a perpetual free tier with 1 user and 100 gigabytes per month totally free. You can try it and make sure that it works for you before it costs you anything. So if you want observability made simple, New Relic is definitely worth another look. Check out their new platform at newrelic.com. All right, so let's take off your Nimbella hat for a second and let's put on your analyst hat if you could for me. So, if you look at, you said earlier, that sort of Kubernetes is starting to get, sort of become the de facto standard for containers. And I think I agree with you there. There's a lot of surrounding tools that are also maturing and sort of becoming sort of the standard there. One thing we don't really have a standard with, though, is serverless, right? And the way that people are, and I should take that back and say more serverless functions, right? So the way that people are building functions as a service. So we have Lambda, which runs on its own proprietary, it's open source, but Firecracker, sort of to run it as close to the metal as possible. Microsoft Azure, you've got GCP, but GCP is also doing not only Google Cloud Functions or Google Functions, and then they also have their Cloud Run and some of these other things. Oracle FN, I think, is also like a Cloud Run type thing. You've got Fargate. You've got edge providers. So we've got Cloudflare with their workers. We've got Fastly. You mentioned all of these, other companies like the Salesforces and Adobes and building their own, either running on top of something else or building their own, running their own serverless platforms that are integrated into their systems. So, there do not seem to be any standards. There are a lot of different approaches. I know there's the cloud events, cloud native working, whatever it is. The Cloud Native Foundation is trying to do this like working group for events and standardize that. But just what are your thoughts? Are you concerned with all of these different approaches to serverless?
Concern isn't the word I would use. And I think we're in a phase where there's room for a lot of innovation and exploration. I think everybody recognizes there's giant opportunities here. So it's greenfields everywhere. Change the context a little bit and hey, you can go a long way. Taking a pragmatic approach, when we looked at this standards issue, we said there is a de facto standard. It's Lambda. And that's because they process more functions on any given month than any other cloud provider, as far as I know. I think the number is in the trillions. And I remember, my first conversation with Tim Wagner at a New York City serverless conference 5 years ago, where he said, I asked him, how many do you do a day? He was like 2 billion, right? So it's been exponential growth, over that 5 years to where they are today. But as you also said earlier, it's this tiny fraction of all the serverless compute, all the compute that's happened in the cloud today. So we got a long way to go. And I think there will be standards or, efforts to standardize will rise. And you're sort of seeing it. So Google has this Knative project. And as part of that, they have been looking at, okay, what does the interface look like? Can we standardize it? And because there's it's got the K in the name, right? It's sort of riding on the Kubernetes wave. It has an opportunity to sort of become a standard, just like Kubernetes is effectively a de facto standard now for container orchestration. So I think we need this kind of exploration. And I think we're seeing exciting technology being developed because of it. And, what's happening at the edge with Fastly and Cloudflare is really exciting. WebAssembly and, the future of isolates where you're running containerless functions, from a computational efficiency perspective really excites me. I don't think end users will eventually care. They'll just care about the interface. So because of that, there will be some standardization. As a startup, we can't do that, right? It costs too much,
right.
And it's prohibitive for us. But it has to come from essentially a consortium of big players. But everybody has a stake to play today, and so I don't see it happening anytime soon. And if you're a pragmatist, you look at who's the biggest whale, and it's Lambda, and you say, okay, they're the standard, and you see it. Auth0, the signature is very obvious. Netlify is very obvious. They're all Lambda, and so it's winning, without actually being declared a standard. Will that change? Possibly, but I don't think we're going to wait around for it.
Right. Right. So what about, so with these different approaches to serverless, I mean, for some people, it makes a lot of sense. If I'm an enterprise and maybe I have, partial workloads on-prem, I have some things running in the cloud, maybe I want to mix and match. And I've got a operations team that can manage my Kubernetes cluster for me or can deal with all this stuff. That's a lot different than your small startup or somebody who is, just hacking on the side or something like that. So, how much do you think these different approaches to serverless are sort of targeted at, maybe the different persona of people who are using it?
I think there's a couple of ways of looking at this. One is, from the operations side, and the other is from the end user side. Actually, I'll give Knative project here a shout out, because I think when they came on the scene, they did a really good job of sort of separating the different persona dealing with serverless. There's the operator, which is managing the infrastructure, the Kubernetes, the VMs, the infrastructure that you're actually running on. And then there's the end user, which is building code and deploying it to this platform. Their concerns are completely different. And so I think you have to approach it in different ways. From an enterprise perspective, they care about both. And you can look at some organizations that have gone all in on AWS, the Lego Group, Capital One. There's dozens of them, Vanguard. And they recognize the transformation they can get by essentially just delegating all that infrastructure, worry to AWS. But it's a process and it's a journey. So it takes time to get there. And if you're a small company, you're a small business, you don't have time for all of that. So your time to market is what's most important. You're going to look at which cloud can I build on that will give me the best solution. And in some ways, the choice that you make really becomes impossible to revert, because the more you build, the more you're essentially tying yourself to that platform. And if you're extracting value out of it, great. So for the most part, if we talk to somebody and they say, we're on AWS, we love AWS, we're like, great, we are not the solution for you. And we sort of recognize that. And we would do the same thing. But there are organizations for various reasons. I mean, just because they're running Kubernetes, is an indicator that you have to meet them where they are. They have needs where they want to operate their own infrastructure. They want to be able to run the same kind of environment on multiple clouds, data gravity or other kind of concerns. You have to be able to give them that serverless experience, because I think their developers are going to demand it. So there's a bifurcation there between the operator and the developer, but serverless can help serve both in different ways. One, on the developer experience and sort of normalizing what you're coding against from an end user's perspective. The other is the operator, where now you can have smaller teams managing infrastructure because Kubernetes does a lot of the heavy lifting for you. And you can extract some of that value and now repurpose it to extracting sort of greater business impact in the long run. And actually, if I answered your question, it was sort of, I took it in a couple of different directions. But I think it's a really interesting area for us, even as a business perspective, has implications.
I'm not even sure what my original question was, but let me follow up with this. And I hate to ask you about vendor lock-in because it's just one of those things where, again, you take a million different approaches to serverless, you pick one, and in some cases, that's it. You're sort of stuck with that. At least from a compute and certainly from a managed services perspective. I think, if you pick DynamoDB, that's a task to migrate to Mongo or to do something like that. I mean, you pick any database, you're pretty much locked in for it. But I'm just curious, sort of from your perspective, and I know that that there's it's more anecdotal, but how important is portability, do you think, for some of these larger enterprises?
I think it's important, but maybe not for. But it's important because we've had the conversations with very large organizations, and some have said something as simple as this: we can run on any cloud as long as it's this one name on the list, right? So there are business reasons for why some companies must run on a particular cloud, and so the lock-in aspect comes about. Like you said, once you start building, and sometimes it just starts by enterprise and developers. One of the early choices I made with OpenWhisk was to use CloudInt, which is an IBM CouchDB as a service. And why did I use it? Because it was just there. I needed a database. I didn't want to worry about it. I just used it. And I regret that choice to this day. I should have used a relational database, but IBM didn't offer one. So these choices become really hard to reverse as you grow. And it takes a lot of investment to essentially then move. And unless you're a large organization that can afford to spend hundreds of millions or billions of dollars, that choice for me is almost a non-starter. But it's there. People actually are trying to do this. And I think whether it's by running Kubernetes clusters on different clouds and then having to normalize it, it's just happening. So I've stopped questioning whether it's valid or not. I just recognize there's a massive opportunity because it's happening. And so if you just accept that and say, okay, what are they missing? And it's this whole serverless notion, because it empowers their developers, it empowers the organization that generates the most value. That's where we focus. So our notion really isn't to look at Kubernetes, it's how far up the stack we can go. And in some ways, because we're a small company, we're highly focused, we can push up the stack much faster than some of the other companies. And this is what gives entrepreneurs and startup founders the opportunity to compete in this space.
Yeah, love that. All right, so before I let you go, I'd love to sort of ask you. I mean, we talked a lot about state and the need for state, and maybe there's the need for better controller mechanisms to spin up or scale up serverless faster. Whether that's pre-provisioning or something like Cloudflare workers are doing, where supposedly it's 0 millisecond cold starts right in there, and of course they can only run, I think, for 30 seconds or something like, or it's very small amount of time, or 50 milliseconds. It's a very small amount of time that those can run for. But anyways, so what are some of the unmet promises? Let's put it that way. Like, besides the state aspect of it, like what else are we missing from serverless? I mean, what do you think that there's, companies like you have to keep solving for?
I think accessibility of the platform. And I remember when I first met you, we had this conversation about, we called it serverless bubble at the time. Right. Maybe bubble isn't the right word because bubbles burst and that's not a good thing. Maybe echo chamber is better. But I think one thing I've learned, and I learned this very early on when I left IBM and sort of went to a developer conference and said, yeah, there's this thing called serverless. It's the greatest thing. And it was like, what? What's a microservice? And sort of recognizing that the world hadn't yet caught on. There is part of the technology community that has, and sort of good for them, but recognizing that there's still large interest in Kubernetes, there's still large interest in EC2 instances and VMs. There's a massive world out there where building applications for a cloud is still hard. Just log on to the Amazon console and look at everything you can get. Where do you get started? So the opportunity for us is making the cloud more accessible. And so we like to think that, from an developer perspective, you can create an account within 60 seconds. you can deploy your first project, not even having to install any tools right out of GitHub. And hey, I have stood up an entire application. It's got a front end. It's got a dedicated domain. It's served from a CDN. My functions are entirely serverless. They scale. I can have state. I just did that, right? So it's about really making the cloud accessible for a large class of developers, from the enterprise all the way to the indie developer who just has an idea for a mobile app or a website that they want to build. I think this is where really the opportunity is. Whether you're running things in a container or an isolate like Cloudflare does, it becomes an implementation detail nobody's going to care about in the future. It's what is the programming experience? How fast can you let me create? And so at Nimbella, we like to say, create, build and deploy at the pace of your innovation. That's what we really want to try to do. So that's what excites me about this. Like serverless is this transformational and even transcendental technology because it can unlock all of that. And hopefully you can tell how excited I am just talking about it.
No, that's, I think you make a really good point. And I always argue that, serverless, when it first sort of came out, right, when we first started building Lambda functions, it was so easy. It was simple. It was a really simple way to think about it. And then it just got more and more complex and more and more complex. And now we're at a point where if you log into the Lambda console on AWS, I mean, it's mind numbing because where do I even start? So I think that is a very lofty goal. I totally agree with you. So good luck with all of that stuff. Rodric, thank you for joining me and telling the story of the IBM and OpenWhisk and what you're doing at Nimbella and just giving me that analysis of the serverless sort of market and what the future is, because I think it's a really messy place right now, and it's got a long way to go. So the more people we have like you that continue to shape it is great. So if people want to get a hold of you and contact you, how do they do that?
So I'm on Twitter at Rabbah, my last name. I'm also easy to find by email, rodric@gmail or rodric@nimbella.com. And I think you'll share some of my contact information later.
Right.
But Twitter is where everything happens today. So at Rabbah on Twitter, and you can find me there.
Awesome. All right. Well, again, thank you so much. We'll get all that stuff into the show notes. It was great to have you.
Yeah, thanks for having me. And really, thanks. I really enjoyed it.
And that's this week's Serverless Chat. I want to give a huge thank you to Rodric Rabbah for being my guest this week, and to our sponsors, New Relic and Amazon Web Services. If you want to check out the show notes and a full transcript of this episode, you can find them at serverlesschats.com/78. For more Serverless Chat, subscribe, sign up to be an insider, check us out on YouTube, and follow us on Twitter, Facebook, and Instagram. You can connect with me on Twitter at Jeremy_Daily. And if you want to keep up to date on everything serverless, make sure you subscribe to the Off by None newsletter at offbynone.io. Thank you so much for joining me, and I look forward to chatting with all of you again next week.